Look at this image. Every speck of light you see here is an entire galaxy. The observable universe stretches 93 billion light-years across and contains roughly 2 trillion of them. Everything inside those galaxies, the stars, the planets, the dust clouds, and you and me, is made of what physicists call ordinary or baryonic matter. It is the stuff we can see, touch, and measure. But if you take all that ordinary matter and weigh it against the total mass and energy of the cosmos, it accounts for exactly 4.9%. The remaining 95% of reality is completely invisible to our telescopes, our eyes, and the entire electromagnetic spectrum. We live our lives inside a tiny, glowing fraction of existence. To understand the forces actually governing the cosmos, we have to look past the light and map the dark. 13.8 billion years ago, the Big Bang triggered a rapid expansion. As the incredibly dense, hot plasma cooled, subatomic particles stabilized, eventually forming the first hydrogen and helium atoms. Over hundreds of millions of years, gravity pulled those early clouds of gas together, compressing them until they ignited into the first stars and grouped into the earliest galaxies. But when astronomers observe how modern galaxies spin and cluster, the math breaks down. The mass of visible stars and gas does not generate nearly enough gravitational pull to keep them intact. By the standard laws of physics, these galaxies should be flying apart. That means every star and planet within our 5% slice of reality relies on a hidden gravitational anchor holding it all together. That anchor is dark matter. Making up roughly 27, dark matter forms immense filaments that intersect into a vast gravitational web. Ordinary matter flows along these unseen filaments, pooling into the densest nodes to form galaxy clusters, leaving vast voids between. We see evidence of this invisible mass in this galaxy cluster. Look at the prominent blue curved streaks of light. Those are distant galaxies behind the cluster. The foreground dark matter is so dense, its gravity physically bends and magnifies the light traveling past it. Without this invisible skeleton to gather gas into dense pockets, our universe would have remained a thin, uniform mist. There would be no galaxies, no stars to fuse heavy elements, and no planets to support life. If you add up the gravity of all that ordinary matter and all that dark matter, the inward pull is immense. Logically, this combined gravity should be slowing down the expansion of the universe over time. The 1998 discovery of distant supernovae, like the one marked by the arrow here, forced a rewrite of modern cosmology. The data proved that the expansion of the universe is actually gaining speed. This brings us to the remaining 68.3% of the universe, dark energy. Unlike dark matter, which clumps together in pulls, dark energy is an intrinsic property of empty space itself. It functions as a compounding engine. As the universe expands, it creates more empty space. Because dark energy is a property of space, more space generates more dark energy, which in turn pushes galaxies apart faster and faster. Dark energy is the dominant architectural force in the cosmos, actively pulling apart the delicate gravitational web that dark matter spent billions of years building. The night sky serves as the battlefield for a massive, invisible tug of war between the contracting pull of dark matter and the accelerating push of dark energy. Because dark energy already accounts for 68% of the universe, and because its influence only grows as space expands, the math points to an inevitable conclusion. Dark energy is guaranteed to win. This trajectory leads to the Big Freeze. The accelerating expansion will eventually isolate every galaxy, pushing them beyond the reach of each other's light, leaving a cold, lonely, and eventually dark void. It took 13.8 billion years of cosmic evolution for the matter in our tiny 5% slice of reality to organize into thinking beings, look back into the dark, and deduce the existence of the other 95%. We do not sit at the center of the universe, but we are its lucky, self-aware observers.